Growing the plants has become the easiest part. All those crops take a lot of hand labor. And our biggest challenge is people in making that part of it work. We need more people.
Wonder, who will be growing our food in the future? On top of that, farm work itself isn't exactly a walk in the park. Backbreaking labor takes a toll on the body, leading to injuries and health problems. It's a vicious cycle. The tough work discourages younger folks from joining a field that's already short on hands. But beyond the immediate challenges of feeding everyone and finding enough workers, there's another big factor at play: sustainability. Those tried-and-true farming methods, while productive in the past, can wreak havoc on the environment. Overusing pesticides and fertilizers can pollute water, wear down soil, and lead to a heartbreaking loss of wildlife. With climate change knocking on the door, adopting sustainable practices isn't a maybe someday anymore. It's a critical must-do. This isn't just some abstract worry. Farmers are facing these challenges head-on every single day. New farmers, especially those without land passed down through the family, face a giant hurdle just finding affordable plots. Cities are expanding, swallowing up valuable land while existing farmland is under attack from erosion, nutrient loss, and salinization, fancy word for when salt builds up in the soil. Keeping our soil healthy is essential for sustainable farming, and losing it is a major threat to future food production. Money woes are another roadblock, particularly for smaller farms. Getting access to loans or financing is tough, making it hard to invest in new technologies that could boost efficiency and yields. These fancy gadgets, like precision agriculture tools and automation equipment, offer solutions for labor shortages and managing resources, but they come with a hefty price tag. This ends up pushing smaller operations to the sidelines. Even sustainable practices like planting cover crops or using natural pest control add another layer of financial burden, requiring upfront investments that many simply can't afford. Climate change is also casting a long shadow on agriculture. Unpredictable weather patterns, think more frequent and intense droughts, floods, and heat waves, can devastate crops and slash yields. Farmers have to adapt their ways to cope with these changing conditions. This might involve using new crop varieties that can withstand heat or drought better, or shifting planting times to avoid periods of extreme weather. On top of all that, there's the constant threat of pests, diseases, and invasive species. These uninvited guests can cause serious damage to crops, hurting farm profits. The emergence of new and resistant pests and diseases adds another layer of complexity, forcing farmers to constantly adjust their strategies to combat these evolving threats. The rise of the agrobots. Well, things are about to change. A new kind of helper is rolling onto the scene to tackle some of agriculture's biggest challenges: the agribot. These innovative machines, basically farm robots, are poised to revolutionize the way we grow our food. Imagine vast fields being tilled by giant self-driving tractors, their every move pre-programmed and guided by fancy sensors. Now picture a tiny robot zipping around a crop like a high-tech insect, using its cameras to scout for pesky bugs. These are just a taste of the incredible agribot world. These tireless farm hands come in all shapes and sizes, depending on their job description. Some have sturdy wheels to cruise across fields, while others might have tracks for handling rough terrain. There are even flying agrobots that take to the skies for tasks like crop dusting. A planting robot, for instance, might scoot around on wheels, while a crop dusting buddy would need a lightweight frame to fly efficiently. But how do these agrobots know what they're doing? It all comes down to a toolbox full of super smart sensors. One key player is LiDAR, a tech that uses rapid laser pulses to create a detailed 3D map of the environment. Think of it as the robot's laser vision, helping it navigate safely and avoid any bumps in the road or field. Cameras are another must-have, providing high-resolution views for all sorts of tasks. They can even assess how ripe a fruit is by looking at its color, acting like the robot's digital eyes to monitor crop health and spot any problems. And to get the full picture of what's going on underground, agrobots use special soil sensors. These little guys dive beneath the surface to measure things like moisture, nutrients, and temperature, giving the robot a heads up on the unseen world below the crops. The brain behind the brawn of the agrobot is a powerful processing unit that analyzes all this sensor data and makes decisions in real time. Imagine an AI-powered fruit picker. The camera sends info on fruit color and ripeness, and the processing unit analyzes it all, telling the robot's arm exactly when and how to pick. Through this powerful combo of sensors and processing power, agrobots are learning to see, think, and act with ever-increasing smarts. But how does the agrobot actually do the work? Here's where the action stations come in. Electric motors are the workhorses for many agrobots, providing the power to move and operate all sorts of robotic arms and tools. These can be wheels or tracks to get around, steering mechanisms to stay on course, and even special manipulators to operate different tools. For example, an electric motor might power the wheels of a planting robot or drive the arms of a weeding robot that precisely removes unwanted visitors. However, for some heavy-duty jobs like tilling, planting, or harvesting, a more powerful system is needed. This is where hydraulics come in. These systems use pressurized fluids to generate powerful movements. Imagine pistons in a hydraulic cylinder, pushing and pulling with enough force to lift heavy equipment, dig furrows for planting, or operate harvesting machinery. For tasks requiring delicate handling, agrobots often use robotic arms. These multi-jointed wonders offer a high degree of flexibility and control. They can be used for picking delicate ripe fruit or for more forceful actions like grabbing and removing weeds. The choice between electric motors, hydraulics, and robotic arms depends on the specific job at hand. By combining these different systems, agrobots can perform a wide range of tasks with impressive efficiency and precision. The billions saved. Cost efficiency. These innovative machines are not just changing the way we farm, they're also transforming the economics of agriculture, with the potential to save billions of dollars annually. Let's dive into the specific ways agrobots are revolutionizing farm finances. One of the most significant cost-saving benefits of agrobots lies in their ability to reduce reliance on human labor. The agricultural workforce is shrinking globally, with many young people seeking opportunities in urban areas. This shrinking pool of labor, coupled with rising wages, makes it increasingly difficult for farmers to find and retain qualified workers, especially for physically demanding tasks.
Our goal is really to empower farmers and field workers. It's to augment people when they are on the field and makes the work less strenuous and more comfortable and more enjoyable.
Agrobots offer a compelling solution by automating various labor-intensive activities. Imagine a world where robots take care of planting, weeding, and harvesting. A reality that's fast becoming a reality. This frees up human workers for more strategic roles in farm management, such as overseeing operations, analyzing data, and making informed decisions. The result? A twofold benefit: reduced overall labor costs and maximized productivity from the existing workforce. Traditional farming practices often rely on a certain degree of guesswork, leading to inefficiency and wasted resources. Agrobots, however, usher in an era of precision agriculture, where every action is guided by data and real-time information. Imagine a robot farmer equipped with an army of sensors. These sensors measure soil moisture, nutrient levels, and crop health, providing a wealth of data that allows the robot to make informed decisions about resource utilization. For instance, sensor-driven irrigation systems deliver water with pinpoint accuracy, ensuring it reaches crops precisely where and when it's needed. This minimizes water waste, a crucial factor in regions facing water scarcity. Similarly, robots equipped with computer vision and targeted herbicide application can eliminate weeds with minimal impact on surrounding crops. This reduces the need for broad-spectrum herbicides, which are not only expensive but can also harm beneficial insects and soil health. By optimizing resource use, agrobots minimize waste and ensure that every input, from water and fertilizer to seeds and herbicides, is utilized for maximum efficiency. Agribots not only reduce costs but also enhance overall farm efficiency and productivity. These tireless machines can operate for extended periods, completing tasks more quickly and consistently compared to human laborers. Imagine an automated harvester operating 24/7 during peak season, minimizing losses due to delays and ensuring timely harvesting of crops. Additionally, the precision planting agrobots serve as the tireless workforce, putting that intelligence into action. By using satellite imagery, drones, sensors, and other cutting-edge technologies, farmers can create detailed field maps. These maps aren't just visual representations of land. They are treasure troves of information, revealing variations in soil health, crop growth patterns, and environmental conditions. Armed with this wealth of data, farmers can move beyond traditional one-size-fits-all practices and embrace a more targeted approach. Imagine a farmer able to pinpoint the exact areas of a field that require fertilizer or irrigation. Data-driven farming makes this a reality. By analyzing sensor data on soil moisture levels, nutrient content, and weather forecasts, farmers can apply fertilizers, water, and other resources with pinpoint accuracy. This precision approach minimizes waste and ensures that crops receive exactly what they need to thrive. Not only does this optimize resource usage and reduce costs, but it also promotes sustainability by minimizing environmental impact. Data-driven farming empowers farmers to become stewards of the land, ensuring the health of the soil and reducing reliance on chemical inputs. Agrobots are the physical embodiment of data-driven farming principles. These increasingly sophisticated robots perform a wide range of tasks, transforming farming from a labor-intensive endeavor to a data-driven operation. Imagine a fleet of agrobots working tirelessly across a field, some equipped with AI that analyzes data from various sensors to make real-time decisions about planting, irrigation, and harvesting. This data-driven approach ensures optimal crop growth and maximizes yields. Agrobots are not simply replacing human labor, they are opening doors to new possibilities. For instance, agribots capable of picking fruits, vegetables, and even delicate crops like grapes are addressing labor shortages in the agricultural industry. These robots, equipped with dexterous manipulators and advanced vision systems, can harvest crops with efficiency and precision, minimizing damage and ensuring optimal quality. This frees up human workers to focus on higher-level tasks such as farm management, data analysis, and overseeing the overall agricultural operation. Data-driven farming coupled with agrobots is a boon for sustainable agriculture. Imagine agrobots equipped with computer vision and machine learning that can identify and target weeds and pests with incredible precision. By using targeted application methods, these agrobots can control weeds and pests without resorting to broad-spectrum chemical pesticides. This not only reduces environmental pollution, but also protects beneficial insects and promotes a healthy ecosystem within the farm. While the potential of data-driven farming and agrobots is undeniable, there are challenges that need to be addressed. One key challenge lies in data collection, ensuring the accuracy, quality, and accessibility of the data that drives decision-making. Data collection in agriculture can be complex, and current methods can be laborious and heterogeneous, making it difficult to develop transferable data models. Furthermore, ensuring reliable rural internet access is crucial for implementing data-driven technologies in remote areas. The environmental impact. However, the rise of agrobots in agriculture presents a fascinating paradox. These innovative machines promise a future of efficiency and economic prosperity for farms, but their environmental impact remains a complex question. While agrobots offer significant potential for sustainable practices, careful consideration is needed to ensure a truly green future for agriculture. Let's take a look at the environmental benefits and drawbacks of agrobots. Navigating this intricate landscape. One of the key environmental benefits of agrobots lies in their ability to facilitate precision agriculture. Traditional farming practices often rely on estimations and experience, leading to the overuse of resources like water, fertilizer, and pesticides. Equipped with sensors that gather real-time data on soil conditions, crop health, and weather patterns, agrobots empower farmers to make informed decisions about resource use. This not only minimizes waste, but also promotes sustainable practices by optimizing resource utilization. Water scarcity is a growing threat to agriculture worldwide. Sensor-driven irrigation systems, often integrated with agrobots, offer a beacon of hope in this arid landscape. Imagine a future where every drop counts. These systems deliver water precisely where and when it's needed. This targeted approach minimizes water waste, a crucial factor in arid regions. For instance, soil moisture sensors can provide real-time data on the water content in various parts of the field, allowing for irrigation only in areas with insufficient moisture. This not only conserves precious water resources but also reduces energy consumption associated with water pumping. Overuse of fertilizers not only increases production costs, but also contributes to environmental pollution. Data collected by agrobots on soil nutrient levels allows for targeted fertilizer application. Imagine a future where crops receive exactly the nutrients they need. By applying the precise amount of specific nutrients, agrobots minimize fertilizer runoff into waterways. This curbs the harmful algal blooms that disrupt aquatic ecosystems and threaten biodiversity. Traditional broad-spectrum herbicide application often harms beneficial insects and disrupt the delicate balance of the farm ecosystem. Imagine a future where weeds are targeted with precision. Agrobots equipped with computer vision and targeted herbicide application can eliminate weeds with minimal impact on surrounding crops. Cameras can identify specific weeds, allowing for the application of herbicides only to the targeted plants. This not only reduces the overall use of herbicides but also promotes a more sustainable and ecologically friendly approach to weed control, fostering a healthier farm ecosystem. Despite the promising aspects of agribots for environmental sustainability, some potential drawbacks require ongoing research and responsible development. While many agribots are currently powered by electric motors, a positive step towards reducing reliance on fossil fuels. The source of electricity powering these machines is crucial. If they rely heavily on non-renewable sources like coal, their environmental benefits may be diminished. The development of clean energy solutions like solar-powered charging stations for agrobots is essential to ensure a truly sustainable footprint. The manufacturing process for agrobots can be resource-intensive, and the disposal of these machines at the end of their lifespan needs careful consideration to minimize environmental impact. Life cycle assessments that consider the environmental costs of manufacturing, operation, and disposal are crucial for ensuring the overall sustainability of agrobots. Sustainable practices throughout an agrobot's life cycle are essential for achieving a truly green future for agriculture. Extensive reliance on agrobots for tasks like tilling and planting could potentially lead to soil compaction and degradation, particularly if not managed thoughtfully. Imagine a future where healthy soil is prioritized alongside efficiency. Sustainable practices such as crop rotation and cover cropping emphasizes environmental responsibility. This journey requires collaboration between farmers, engineers, and environmental scientists to unlock the full potential of agribots while mitigating potential environmental drawbacks. Several crucial steps can pave the way for a sustainable future. Fossil fuel reliance on agribot operation undermines their environmental benefits. Integrating renewable energy sources like solar and wind power into agribot operations is essential. Imagine fields dotted with solar-powered charging stations, ensuring agribots operate on clean energy, reducing greenhouse gas emissions, and contributing to a greener agricultural sector. A holistic understanding of an agribot's environmental impact is crucial. Encouraging manufacturers to conduct life cycle assessments that encompass the environmental costs of manufacturing, operation, and disposal can highlight areas for improvement throughout the machine's lifespan. By optimizing resource use during manufacturing, minimizing energy consumption during operation, and developing sustainable disposal practices, we can ensure a truly eco-friendly life cycle for agribots. Integrating agribot use. With established sustainable farming practices like crop rotation and cover cropping is vital for long-term soil health. Crop rotation helps maintain soil fertility and reduce reliance on fertilizers, while cover cropping minimizes soil erosion and promotes beneficial organisms. Imagine a future where agribots coexist seamlessly with these sustainable practices, creating a synergistic relationship that fosters a healthy and productive agricultural ecosystem. Establishing regulations and standards that ensure agribots are designed and operated in an environmentally responsible manner is crucial. These regulations can address concerns about potential negative impacts on soil health, water quality, and biodiversity. By implementing such guidelines, we can ensure that agribot development prioritizes environmental sustainability alongside technological advancements.
I think the hope is that automation will allow us to create more desirable jobs for people. But I think there is also a threat. The danger I see is that we use robotic automation to displace people, to rob people of the opportunity to earn a livelihood.
The use of agribots has sparked discussions about job displacement in agriculture. However, a more promising perspective is emerging. A future built on collaboration between humans and robots. Agribots are not destined to replace farmers. Instead, they are powerful tools that can empower farmers to become more efficient, productive, and data-driven. This human-robot partnership will rely on several key aspects. Agribots excel at repetitive, physically demanding tasks or those requiring high precision. Imagine robots equipped with advanced sensors and computer vision tirelessly weeding fields, meticulously picking delicate fruits, or performing automated harvesting with minimal errors. Humans, on the other hand, bring invaluable problem-solving, critical thinking, and adaptation skills to the table. Farmers can leverage their expertise to oversee agribot operations, make strategic decisions based on real-time data collected by these machines, and intervene when necessary. This division of labor allows farmers to capitalize on the strengths of both humans and robots, leading to a more efficient and productive agricultural operation. The data collected by agribots provides farmers with a treasure trove of information about their fields, crops, and the surrounding environment. This real-time data empowers farmers to make informed decisions about resource utilization, pest control, and irrigation strategies. For instance, sensor data on soil moisture levels allows for targeted irrigation, minimizing water waste. Similarly, analysis of crop health data collected by cameras on agribots can help farmers identify signs of disease or nutrient deficiencies early on, allowing for timely intervention and improved crop yields. While agribots collect the data, it's the human expertise of the farmer that interprets this information and translates it into actionable insights for optimizing farm management practices. The integration of agribots necessitates a shift in the skill set required by the agricultural workforce. While some traditional manual labor positions may be reduced, new opportunities are emerging in areas like robotics, engineering, data analysis, agribot maintenance, and programming. Investing in upskilling and reskilling programs for existing agricultural workers is crucial to ensure a smooth transition into this new era of agriculture. By providing training opportunities in these emerging fields, farmers and agricultural workers can develop the skills necessary to collaborate effectively with agribots and navigate the complexities of data-driven agriculture. The human element remains essential for ensuring the safe and ethical operation of agribots. Farmers play a critical role in overseeing the operation of these machines, monitoring their performance, and ensuring they function within established safety parameters. Additionally, farmers act as the ethical stewards of agribot use, ensuring these machines are deployed in a way that promotes sustainability and environmental responsibility. This collaborative approach, built on clean energy, responsible development, and a skilled workforce, paves the way for a future of agriculture that is not only efficient and abundant, but also environmentally responsible. Imagine vast fields teeming with crops nurtured by robots powered by clean energy sources like the sun and wind. Farmers, empowered by data and new skill sets, will make informed decisions that optimize yields while minimizing environmental impact. This future of agriculture is not just about replacing traditional methods. It's about leveraging technology to augment human ingenuity and ensure a sustainable food supply for generations to come. Conclusion. Despite these challenges, the future of agriculture is undeniably data-driven. By embracing this new approach and working together, farmers, researchers, technologists, and policymakers can usher in a new era of agricultural prosperity. As we move forward, it's important to invest in infrastructure that improves rural internet connectivity, fosters collaboration between stakeholders, and promotes the development of transferable data collection and analysis methods. By addressing these challenges and harnessing the power of data-driven farming and agribots, we can cultivate a more sustainable, productive, and prosperous future for agriculture, ensuring food security for generations to come. So, what do you think? Excited for the future where all the backbreaking labor is handled by robots? Or are you one of the people terrified by robots replacing humans? Tell us your opinions in the comments below. If you liked this video, don't forget to check out our channel for similar content. Until next time.